I welcome everybody to the third year of these lecture series on clinical nutrition and obesity. Again, this year we're starting a little bit later than we have in the last 2 years, but we hope that this will be an exciting series. And in the back of the room, on the back table, I have left a poster type of program for the whole lecture series that will be taking place this spring. There are only 4 lectures this year, with the next one being on April 13th and entitled Nutritional Findings and Interventions in the AIDS Patient by Donald Kotler. However, this evening, in order to launch the series, we have brought Dr. Judith Stern from the University of California at Davis, and she has been associated with one of our NIDDK-funded clinical nutrition research units there. She's been instrumental in developing an animal models core for the study of obesity there, and has been very active in numerous societies in promoting both nutrition and education, both research and education. As an example of some of her past accomplishments, she is the immediate past president of the North American Association for the Study of Obesity, and she is currently chair of a National Academy of Sciences committee dealing with evaluation of outcome criteria for obesity weight loss programs, and has just recently heard that she will be becoming Vice President-elect of the American Society of Clinical Nutrition. And so we all welcome her this evening and let her begin her talk in telling us about physical activity, metabolism, and weight control, or in her words, the new word is weight management.
Thank you. Thanks very much, Van. I really feel privileged to be asked here to NIH to not only give a research lecture this afternoon, but to talk a little bit about obesity with respect to physical activity and metabolism and diet. And before I start this lecture, I want to thank a few people. Linda Hubbard, do you ever stand up in an audience? Could you stand up just for a minute? We had a wonderful dinner at the Hubbard's house, and I think I had my 5 a day for dinner. And it was just special, and it feels very good to do that. And I want to give you, I think, what's a take-home message that I'd like for you to go away with from this lecture. And that's obesity, and I'm sure you've heard this from many other people, is a very complex disorder. It's more than just eating too much or being less active, and that it has very firm biological bases. And it's when the individual, albeit a human or a genetically obese rodent, comes in contact with perhaps diet that's high in fat or a plentiful food supply or inactivity that, in fact, some of these underlying characteristics can actually blossom, so to speak. And being chair of this committee for IOM has been a challenge. And I think that, while I can't talk about the report because it is embargoed, I think there is consensus among the community that we really fundamentally don't understand why some individuals become obese and some don't. And we think it's very important, for example, that institutions like the NIH continue to forge ahead in trying to find out the basics for what chromosome genes are, what genes are involved in body weight and obesity. But at the same time, we as practitioners have the obligation to our patients and clients to provide the best that we can provide for them. And so the reason why I talk about weight management, it shouldn't only just be loss of body weight, but we're trying to think in terms of physical fitness, better nutritional practices, probably feeling better about yourself, and or the client feeling better about him or herself. And we're trying to get that message across whenever we can. So that was the 2-minute commercial. And now let's talk a little bit about obesity. I'm not going to give you the standard slides that obesity is harmful to health. I'm sure you know about increased morbidity and mortality in the obese. I do have just a few preliminary slides, one of which is from the work of Dr. David Williamson, where he's just looking at incidence of 10-year major weight gain, meaning an increase in 5 basal, meaning body mass indices units among men and women. And men are shown in the open bars and women in the closed bars, and it comes probably not as a surprise to many of us women that from the ages of 25 even to 74, women gain more weight than men do. And that it isn't just the amount of weight you gain or your body weight or even how fat you are, but in fact, it depends in part where the fat is distributed. And we're talking about a waist-hip ratio to clinically get at that. And for example, if an individual has an elevated waist-hip ratio, he or she is at greater risk for diseases associated with obesity, such as diabetes, hypertension, and the hyperlipidemias. And here we're looking at age, and on the y-axis we're looking at waist-to-hip ratio, and let's just focus on men, that you can see as men in the very high-risk category have elevated waist-to-hip ratios. Same thing with women, only women normally don't have an upper body fat distribution, and again, as waist-hip ratio increases, one is increasing the risk associated with obesity. And the final point or two that I'd like to make before going on to some data slides is something that we all know, either personally or professionally, is that once an individual takes weight off, it's extremely difficult to keep it off permanently. And here is this woman saying, I lost 2,000 pounds, and that wasn't because she weighed 2,200 pounds, but because she lost weight and gained and lost and gained weight. And the next slide just presents the data in terms of diet success rate. And I must say that I object to sort of the heading. We're talking about weight loss. Now, if we look at the statistics, the end of therapy, after 1 year, after 5 years, it really doesn't matter what treatment you're looking at, whether it's diet alone, behavior therapy, or any combination. The point that we all know who treat obesity is that at the end of 5 years, probably even at the end of 9 years, that the vast majority of people who lose weight regain the weight back. And again, I take that to mean that there are strong biological bases. And it isn't because, and I'm a rat doctor, that you're either a bad rat if you don't lose weight, or you're a good rat. And this was from a greeting card. I just felt that I had to show it to you. And it isn't because you eat snack food that you're fat. And I hope to present what I think are some compelling data using animal models, and also showing you some data from the human, from studies of humans. So the first thing that I'd like to talk about using data from animal models and humans is the effect of diet, then exercise, ending up with genes, and not Calvin Klein. Okay, so let's focus now on changes in the American diet. And if we look at the proportion of energy from carbohydrate, fat, or protein, and we compare 1910 to 1980, clearly the amount of fat, or the proportion of fat, has increased in the diet. And meeting with Barbara Moore this afternoon, she told me that NHANES 3 tells us now that we've gone down from about 38% of calories from fat to about 35 or 34% of calories from fat, and that's encouraging. However, she also told me that people are eating a little bit more, and people are fatter than they were even 6 years ago. And as a healthcare professional, I am concerned that some of the guidelines that we've set out for Healthy People 2000 in reducing obesity in adults and in kids simply won't be met. And either we have to reevaluate the Healthy People 2000 goals, or we have to do a great mid-course correction. I just don't think they're very realistic or obtainable or even perhaps desirable given now what we know about obesity. And in the question period, I'd be happy to talk more about that if you like. Well, this is a slide from the work of Dr. Elliot Danforth. And what this shows is he's looking at the amount of weight gain by overfeeding a mixed diet for 7 months or a diet very high in fat for 3 months. And what you can see is for the same amount of weight gain, you gain fat or weight more easily on a lower caloric excess. And so in fact, that probably underlies some of the basis for telling the American public to cut back on fat. Now, we've taken the approach to study these biological differences in a number of different animal models of obesity. And one of the rats that we use is the Sprague Dawley rat. It's just the good old, normally lean white rat. And what we do with this animal is we feed it a very palatable diet, the equivalent of a high-fat, high-sucrose diet. And lo and behold, what we did was we fed these Sprague Dawley rats this high-fat, high-sucrose diet for a period of about 3 months. And what was remarkable was that some animals everybody increased their percent body fat. The leanest animals were about 20% body fat. But we had a small but significant number of these fatty rats that were over 50%, had over 50% of the body weight in terms of carcass lipid. And this is as fat as any genetically obese animal. So you can look at the final distribution of body weights. These animals started, they were pretty much homogeneous. And if you look at carcass lipid, there are a number of animals that are quite fat. And also there is a distribution in lean weight. And the question would be is if there's a way to predict this individual variability, that could be a bonus. And what this shows is that the animals that were more efficient in terms of food intake gain more weight, and that shouldn't be surprising. And basically that, in fact, these show the differences in quartiles, final body weight and carcass composition. And let me tell you how we divided the final body, these into quartiles. Before the animals were exposed to this wonderful rat diet, we took a little bit of adipose tissue, a little bit of fat from one of the subcutaneous areas, and we put it in a test tube, and we stimulated it with epinephrine. And we just measured the amount of fat that was, the amount of glycerol that was released and free fatty acids that were released from the triglyceride. And they were a group of rats that were quite resistant to epinephrine-induced lipolysis. And we said that maybe these might be the obesity prone. They would tend to resist mobilizing fat. And then there were a group of rats that really quite readily responded to epinephrine. And what we found out was that the low responders, meaning the low response to epinephrine, had much more lipid at the end, after we fed them, than the animals that were the high responders. And also their carcass lean body weight was a little bit higher, and certainly their final body weight, but there appeared to be a pretty robust effect in terms of body fat. And Dr. Barry Levin has an even easier measure to predict, and he just looks at 24-hour urinary catecholamines and gets very robust correlations of about 0.9 before these animals become obese. So that might be potentially a biological marker that one could use to predict which animals or individuals might get fat when exposed to a high-fat, high-sugar diet, so to speak. Now, the next thing that I'd like to talk about is troublesome in the sense that I don't think that we have the final word on it. And the question is gaining weight and losing weight and gaining weight deleterious, weight cycling? And about 5 years ago, I'd say definitely it's deleterious, because we had done a series of studies to show, and this was along with Kelly Brownell and Judy Roden and Marcy Greenwood, this is the imperial we, so to speak, looking at some of the Framingham data to show that men whose weight changed the most had the highest morbidity, mortality. We did some studies with rats to show that animals that went through 2 or 3 weight cycles, seem to get a bit fatter or eat more. And we also did a study with exercise to show that when animals basically were weight cycled and then allowed to refeed, the animals that didn't exercise selected very little carbohydrate in their diet. But if they exercised along with weight cycling, in fact, they selected a fair bit of carbohydrate compared to the normal animal. And the good news that we were very excited about was fat selection was elevated in weight cycling animals, but decreased in animals that not only weight cycled but were exercised. But the results were, in fact, very controversial. Most people didn't find this, and there is an NIH consensus document now about weight cycling that says, basically, and I'll be reading it tomorrow, that really weight cycling isn't deleterious to health. And I was all ready to tell you this, and 3 days ago I picked up my newspaper, which often is how I get some of the science, the latest breaking science, to read that Steve Blair at the Cooper Institute at University of Texas reported at an American Heart Association meeting that men whose weight fluctuated multiple times, as little as 10 pounds, had higher incidences of coronary heart disease. So I guess I would say that it's hard for me to resolve this instantly here, but there may be individuals that are more susceptible to weight loss and regain, and I guess that I really have to read the Blair paper. I've been unable to get in touch with it, but the final word may not be in on weight cycling. But independent of that, I don't think that we should use a possible hypothesis, and it's only a hypothesis, that weight cycling might be deleterious to health, to preventing individuals who want to improve metabolic fitness, who want to try and lose weight and maintain it, from trying it once again. I wanted now to talk a little bit about exercise because based on some of the data we've obtained both in experimental animals and humans and the data that I see in the scientific literature, I am really convinced that exercise is one of the key factors that makes a difference between maintaining a weight loss or putting weight back on. And it's still not clear whether it's a metabolic effect, it might be a psychological effect. I know that I have great discussions with my psychology colleagues that claim, well, individuals that exercise are more determined, they're able to maintain, they're able to have a stabilized regime and reduce stress. And then I speak to my other colleagues who come from the area of metabolism, and they say it's clear that individuals who exercise have lower insulin levels, and so on. They burn up more energy. But nonetheless, what we can report is individuals that do exercise regularly do tend to maintain body weight, lost weight, better than those that don't. And it doesn't mean that all obese individuals are inactive. But certainly if we were to survey the obese population and compare them with the lean population, they tend to be less active. This is a study that was published way back in the 1960s, I like to say before I was born, by Dr. Mickey Stunkard. This was before he went to University of Pennsylvania. And what Mickey did was he just logged in the average daily miles a non-obese man walked, an obese man walked, and then he did the same thing for women. And he had them wear pedometers. You know, he just had them wear it on their waist. They would walk, and at the end of the day, they'd measure it. And on the average, non-obese man walked about 6 miles a day. An obese man walked less, about 3.7 miles a day. And women walked even less. Non-obese women walked about 4.9 miles a day, and obese women walked 2 miles a day. And the way I've used this in the clinic is to try and get people to have some sort of measure of physical activity. And I think pedometers are as good as any measure. And so that if an individual, a woman, let's say, is only walking 2 miles a day, or even 2.5 or 3, we can have her set a goal and gradually increase her goal and increase her activity. So for some individuals, this may be a good way of monitoring physical activity. It's also a way of trying to see if the individual person that you treat is active or inactive. It doesn't work with swimming, however. It's hard to wear a pedometer while you swim. But nonetheless, there's also evidence, some of the old work by John Mayer, that when individuals spend time in physical activity, if they're obese, they are typically less active than their normal weight counterparts. This, again, was a study done quite a number of years ago where Dr. Mayer, the late Dr. Mayer, observed obese and non-obese adolescent girls at a summer camp. And there you have periods of physical activity. And he videotaped them swimming, playing volleyball, and tennis. And what we see on the y-axis is the percent of girls that were relatively inactive, or the percent of time, basically, that the girls were inactive during the period. And what I just want you to take away from this talk is that whether they were swimming, playing volleyball, or tennis, on the average, the obese girls were less active than the lean girls. They were less active than the lean girls and less active than the lean girls. And so again, even if you have patients or clients that say they play tennis for an hour a day, they may be watching the ball go by and chasing it less. So the effort is important to look at. Well, we also looked at the psychological aspects of exercise in obese individuals, and we studied, and this is an old study that I did with Dr. Joel Grinker it must have been 1980 or so. And we went to a summer camp, or actually our graduate student went to a summer camp, and she spent time with obese boys, and they had an intensive physical activity program, and it was a 7-week program. And during this program, the average boy who weighed 177 pounds, after 7 weeks weighed 148 pounds. And that's a huge weight loss for a kid. The percentile above desirable weight, and here we were using the 1959 Metropolitan Life Insurance tables, 44, and it went down to about 19%. Percent body fat, and we were measuring by using skin fold thickness, went from 39% to 27.5%. They were still above the average, but clearly there was quite a drop. And there was no change in lean body mass. And that's because, in fact, literally, these kids were physically active for about 6 hours a day. They were eating about 1,400 kilocalories a day, but they were extremely active. And there was a fitness index where they were looking at the minutes to walk or run 1.5 miles, and it went from a little over 21 minutes to 17 minutes. Well, we had the hypothesis that basically that obese kids, if they were physically active, that they would improve an index of what we call locus of control. And they would also what we looked at with locus of control, and it's a standard inventory. In terms of if a child or any individual was more internally controlled, they basically believe that their own effort leads to rewards. And if they were externally controlled, and they would have a higher score on this Nowicki-Strickland locus of control inventory, they would believe that luck or chance leads to rewards. And the reason why we were interested in studying this is because LOC is supposed to be very stable. It's not supposed to change with weight loss. And our hypothesis was that if weight loss was achieved with exercise, we wouldn't see. We'd see a movement towards a more internal locus of control inventory. And some example of the sample items that were asked on this test was, do you believe wishing can make good things happen? And if you answered yes, then you'd get a higher score under external control. Do you think it's better to be smart than lucky? I think it's better to be both, but they didn't give that option. If you answered yes to this, then it would be a more internal means of control. And the bottom line, and unfortunately we did this without a control group, and I would criticize my colleagues if they did it without a control group. The control group would be obese boys losing weight without exercise, but in such a short period of time, one, it's hard to find. It would be extremely difficult to find. But basically, what we saw was a movement towards a lower score or a movement towards more internal control. And this study was never followed up on, but the thought would be that if you are more internally controlled, that you might have better success with taking control of weight management issues. The other thing that we looked at, but I'm not showing the data for, we looked at some estimates of body size. And the reason why we were interested in body size, because if you were to do this determination in adults, before and after weight loss, and if the adults became obese as adolescents and they lost weight, they would continue to see themselves as fat even after they lost the weight. However, typically, adults that become obese as adults, after that key period when self-image is being determined, with weight loss, they tend to see themselves just the way they are. And what we found out with these obese adolescent boys, and they ranged in age from about 11 to about 16, was with weight loss, they saw themselves just the way they were. So that we never followed up on this, but I think that it would be an interesting thing to look at to see if indeed we could move locus of control inventory for kids that are very externally controlled by using physical fitness. Well, I'm now going to change the tone a little bit of the talk and talk a little bit about metabolism. And basically, these are data from Karen Siegel's studies, and she does extremely elegant work with humans, where she studies obese and lean men, women, et cetera. And here we're looking at lean women, we're looking at obese women, and basically we're looking at the thermic effect of food at each level of activity. And what Karen is showing, what Dr. Siegel is showing is that as one increases basically the level of activity, one increases the thermic effect of food in lean, but not in obese. And so that the obese individual in some ways has the deck stacked against her or him when it comes to some of these effects. Well, our approach to studying physical activity, we took a developmental approach, and we studied rats because we found that they obey instructions a little bit better than patients in some cases. And this is a picture of a genetically obese and lean, in quotes, Zucker rat. It's called a Zucker rat because Lois Zucker and her husband spontaneously found this mutant in their colony of rats. And what we have here is we have actually a running wheel, almost like a hamster running wheel. Typically, you see a cage attached to the running wheel, and the rat, can just stay in that cage and eat, or it can go through the little opening and run in the running wheel. And at the end of the day, we actually count on this counter how many revolutions this animal has run. At 16 days of age, when these Zucker rats just open their eyes and they're still suckling, we put them in this cage, the stationary cage, for several hours a day. And then we weaned them at 21 days, and they were housed totally in this cage. And our hypothesis was that certainly the obese animals would be less active than the lean, but we didn't know when the onset would be. Would the onset of it be after they become considerably obese, and then there are problems with movement, or would it be early on? And as seen in the next slide, and we didn't expect this, prior to weaning, and the lean animals is shown by the solid white line, and the obese animal by the dashed yellow line, there basically is no difference in activity. But we wean them in this particular study. At 24 days of age, there was an increase in activity, probably reflecting deprivation. Rodents, when you deprive them from food, they run more. But immediately thereafter, the obese animals became considerably less active. When we changed the onset of weaning, when we moved it to 21 days, the onset of inactivity moved to 21 days. When we let them stay in the cage with their mom, she spontaneously weans them at around 30 to 35 days because their little teeth are not conducive, I think, to weaning, to continued suckling. And so then we saw an onset of inactivity that was sort of around 35 days of age. Again, we didn't pursue this, but clearly at least inherent in this obese animal before it becomes obese is some degree of inactivity. And it may just be that they're spending more time eating and less time running. And so then what we did in a follow-up study, we fed the obese animal precisely what the lean animal ate. And we restricted them to 50% of their normal food intake, which was less than a lean animal. We got them to be comparably active, and they were somewhat less fat than their ad libitum fed and inactive lean obese counterparts, but they were still very obese in terms of body fat. So from our Zucker rats, you can decrease food intake lower than normal. They can be comparably active, and they still, in fact, are not made normal by these procedures. So there has to be something biological, some basis for this obesity. Now, the sad news about this study is that we took all our rats at 8 weeks of age, and we stopped them from exercising. And we looked at them when they were 6 months of age. And I just present the data from the lean animals. And if we look at the grams of fat in the lean animal that never exercised, it was about 20 grams. But in what we call this formerly active athlete, in fact, it was fatter at 6 months of age than it would have been if it never exercised for about 6 weeks. And this intrigued us, and we went to do a series of studies looking at what we call the retired athlete, albeit a rat. And we looked at several ways of exercising it. In a first study, we were looking at swimming. And this is a study that Janet Wahlberg did when she was a graduate student in our lab. And what she did was she had the animals swim for 8 weeks, and then she stopped them from running. And we had several groups. We had lean animals that swam and didn't swim, and then they became inactive. There wasn't much of an effect here. We had obese animals that basically were pair-fed to the lean animals and kept active. Here we just allowed them to become inactive, and look, body weight is shooting up, even though they're eating what the lean animal is eating. And this is the animal that just swims. It weighs a little bit less, and then when we stop it from being active, it begins to approach the other animal. Now, we had problems in doing this study, though. It's really hard to get an equivalent degree of exercise if you swim an animal that's pretty buoyant, that's fatter. They tend to float. They do float. And so we thought, well, we'll swim them with lean animals. So we'd swim them for about 6 animals, actually in a garbage can. You know those 32-gallon garbage cans? We regulated the temperature of the water. We made sure the water didn't get too close to the top because they'll jump out. And we found some other things, that if the obese animal didn't swim and it floated, which is basically what it did, the lean animals would use it as a stepping stone to hop out of the garbage can. And so I'm just sort of sharing with you some of the things. You have to be somehow inventive. So that Janet came up with the idea, well, we'll give them weights. Because when you look at, not weight training, we'll give them weights. When you look at the position of a lean rat in our swimming pool at UC Davis, their body is at an angle. When you looked at the obese animals, they were floating. So she had one interchange where, and my graduate students have to be inventive, she went to a fabric store and bought Velcro. And she was going to make little belts for the rats and put little weights on it. And she remembers the sales lady saying to her, "Dear, what are you going to make? That's a lot of Velcro." And Janet said, "Belts for my rats." And that seemed to conclude the conversation. So that we then decided perhaps, and swimming, they can inhale the water. It's really very traumatic, not only for the rat, quite possibly, because it's the swim or sink approach, or the sink or swim approach, but also the graduate student. So then we moved to exercising rats using treadmills. And finally, what we did, we wanted to look at the very rapid response to what we called no exercise or detraining. So what we did, and these are just normal rats, these are Osborne-Mendel rats. Typically in this study, we would feed them a high-fat diet, but we didn't have to feed a high-fat diet. And for those of you who read Runner's World, the student who did this study is Dr. Liz Applegate, and she has a monthly column in Runner's World. So when you read it the next time, you can think of Liz doing this study. So what she would do, she would exercise her rats for 6 weeks for about 20 meters a minute, which isn't very fast for a rat, for 50 minutes a day, 6 days a week for 6 weeks. And then suddenly they would stop exercising. And then 24, 48, 60, 72, and 84 hours after they stopped exercising, she studied them. And what I found quite remarkable was the effect on food intake. We had previously observed that when animals, in quotes, detrain, their food intake is elevated 2 weeks after this happens. And now the slide is a little bit confusing because rats eat in the dark and they don't eat in the light. So that's why we have a zigzag picture. But let's focus on the sedentary animals. They're shown by the solid line. Let's focus on the animals who up until now were exercised. This is 24 hours after the last bout. This is 48 hours. And 60 hours after the last exercise bout, they were already eating significantly more than their sedentary controls. They were already eating significantly more than their sedentary controls. And actually, the first thing that we measured was insulin at 48 hours. In animals that typically exercise, insulin levels are low, and they had returned to normal, and there was a slight overshoot at 48 hours. We also measured, or should I say Liz also measured, the activity of an enzyme, lipoprotein lipase. Now, lipoprotein lipase, or LPL, is considered a gatekeeper enzyme for adipose tissue. That enzyme allows the triglycerides to be hydrolyzed, to enter the fat cell, and then to be stored as triglyceride. This is the sedentary animal. This is the animal that exercised just the day before, 24 hours. And you can see that with what we called, in quotes, detraining, there was an increase in LPL activity, or a return to normal over the 72 hours of the study. What was really even, I think, more impressive, that when we studied them in the dark cycle, and this is basically in the fed state, that by 60 hours LPL and by 84 hours LPL was significantly elevated over and beyond what one saw even in the sedentary animals. And you might say, this probably has no relationship to people. Well, it may. And this was a study done by Robert Hawley, published in 1986, and it was done with people who basically competed in the Ironman competition in Hawaii. Now, I think that you have to be a little bit crazy, too. Stop me if it's swim 10 miles, you bike for, is it 100 miles? A lot of miles, maybe 110, and then you run a marathon. So clearly, people who enter this race have to be in very excellent physical shape, and they train a lot. And in fact, one of the experimental subjects, and he was part of a group, was Dave Scott, who that year won the Ironman competition. And we were just looking at serum triglycerides, or Dr. Hawley was looking at serum triglycerides in these triathletes, and initially they clearly are very low. On race day, they are very low, but 5 days post-race day, where they've been exercising considerably less, we see a rise in triglyceride levels. Now, albeit this is a very artificial situation, I don't really feel that many people encounter this type of paradigm. But there are some conditions in humans where sudden cessation of exercise or a sudden increase of exercise does change metabolic rate. And these data are from a study that we did at Davis with female athletes. And they volunteered for a period of 3 days to stop exercise, so that 1 month prior to the period when they stopped exercising, when we could control for the menstrual cycle, we measured their resting metabolic rate, and that's the 0. And then we measured it 1, 2, and 3 days after they stopped exercising, and we found small but significant decreases in RMR with cessation of exercise. And that certainly could, if it was extended, lead to weight gain or weight regain if food intake was not altered. We also did a study that I still think is controversial, and I'll admit the controversy because a colleague of mine, Dr. Steve Finney, finds the opposite, and we're at the same campus. We exchange data and ideas all the time. But what we did in this study, the hypothesis was we knew that resting metabolic rate expressed per body weight to the 2/3 power drops within about 10 to 14 days when individuals are put on very low energy diets. And for this particular study, I think they were eating food and taking in about 500 or 600 kilocalories a day. And our hypothesis was that 2 weeks into this weight reduction program, if we could get them to exercise, we thought that we could prevent or reverse this drop in metabolic rate. And the exercise was at least a half an hour a day at 60% of VO2 max, and they had to do this exercise at least 12 hours prior to the measurement of resting metabolic rate, which indeed they did themselves at home. What we're seeing here is we're looking at individuals on this 500 kilocalorie a day diet over this 2-week period. We're showing a drop of resting metabolic rate, and we're expressing it as percent of their control metabolic rate. And actually, it's better to look at the bottom slide because it's expressing it in a mass-independent fashion, and that's body weight to the 2/3 power. So by the end of 2 weeks, there essentially was quite a significant drop in resting metabolic rate. These individuals did not exercise, and the drop in metabolic rate remained low. These individuals exercised for that period of time. And humans are not like rats in some ways, and as I referred to, they don't always follow instructions. And we found that if there was a day when an individual didn't exercise, that metabolic rate returned to this low level. And our hypothesis was we think that the reason why metabolic rate is up was due to an activation in the sympathetic nervous system. But again, not everybody finds these effects when they study the effect of exercise on metabolism. Well, nonetheless, I hope that I presented some interesting, amusing, and also some convincing data for getting individuals who want to control their weight to try and become physically more active. I don't think there's any really splendid data showing that it aids in weight loss in the sense that it significantly increases the rate of weight loss, especially in women, but it certainly helps in the maintenance of body weight. Now, for the next few minutes, actually 15, I'm going to talk a little bit about genetics and why I'm convinced, one, first, there's a strong genetic component to human obesity, and two, to present some data that have been obtained in our laboratories showing that at least in genetically obese rodents, that there are some metabolic events that occur early on that certainly don't reflect what their mother does to them. The mother isn't overfeeding them, so to speak. And here we're now just looking at parental fatness and obesity in children. And these are the data from Garn. And what I want you to focus on is that basically that for children who have 2 obese parents, this is the percent of children that are obese. That if we look at children that have 2 lean parents, the height of the green bar is the percent of children that are lean versus obese. And this is taken to mean that there is certainly a genetic, but perhaps environmental component. But one can always look at, and I think pictures are worth 1,000 words. These are slides of fraternal twins. And you can see that for some of the twins, there's quite a difference in body shape, probably body weight, body fatness. Certainly here's a dramatic illustration. And the next slide just looks at identical twins. And here, body weight, body fatness, body shape is more identical. You don't see the variation. Well, for those of you that are interested in looking or reading more about the models of genetic obesity that I'm going to talk about, I co-authored a chapter on animal models of obesity that appeared in Annual Reviews of Nutrition in 1991. It also talks about some of the genetics, some of the proposed gene defects, and you might find this instructive if you're interested in knowing more about it. Well, these are our genetically obese sucker rats again. And thanks to the group at Rockefeller University, we know that the reason why one of these animals will become obese and the other will be lean is because there is a defect on chromosome 5. Inheritance of this trait is autosomal recessive. And also the fatty gene has been moved to different backgrounds, and depending on the background of the animal, you can get it. These animals, when they become obese, are not diabetic. But in fact, if it's on a Wista-Kyoto background, that's just another strain of rat, these animals, the males, will become spontaneously diabetic and develop NIDDM with glycated hemoglobins at 3 months of age approaching 13, where normal for their control rat counterpart might be 6.5. So I think they offer a wonderful way to look at how disease might develop and or be prevented in genetic obesity. Now, if we were to look at some of the metabolic characteristics of this obese sucker rat, they clearly have elevated insulin levels. And this afternoon I talked about what I think contributes to increased insulin secretion in this animal. They are insulin resistant. They're marginally hyperglycemic, but not in a clinical sense. They have impaired protein deposition. They're hypothermic. They don't generate heat to cold. They have elevated fat cell size and number, and they have elevated activity of adipose tissue lipoprotein lipase, which even after weight reduction is still elevated. And in fact, obese humans also have elevated adipose tissue LPL activity. Now, this is just a slide to illustrate that even if you underfeed the fat rat prior to weaning, it still develops more fat cells. But let's first look at the lean animal. This is the lean animal, and we're looking at total fat cell number in the lean animal that's just being fed 8 pups to a rat mom. This is a lean animal that's being fed 22 pups to a rat mom. And this is a lean animal there where the mom only has 2 or 3 pups. And they're fed this way, and at weaning, they're allowed to eat ad libitum, and then they're studied at 6 months of age. And you can see underfeeding leads to a permanent decrease in fat cell size, and overfeeding increases fat cell number, excuse me. Decreases fat cell number, increases fat cell number. Now, the bad news is that in the obese rat that's overfed prior to weaning, there's a permanent increase in fat cell number. But in the rats that are underfed prior to weaning, there is no permanent decrease. And in fact, in these fat animals, they continue to make fat cells long after the lean animal stops. Now, this is a slide that was generated from a former graduate student of Dr. Barbara Horowitz. In fact, Vanessa, do I see you back? Vanessa Ruth? I see Vanessa and her husband Mike in the audience. And she was looking at some of the neuromodulator changes in the central nervous system in the Zucker fatty and lean rat. And she also, in this particular slide, identified that the rat, as early as 2 days of age, before they become obviously obese, have blunted thermogenesis. And I'll show you a slide illustrating that in a minute. They have larger fat cells by 7 days of age. And Vanessa was able to show that they are hyperinsulinemic by 14 days of age. Prior to her study, we felt that this didn't occur until about 21 days of age. And they increase their food intake, they're hyperphagic by about 18 days of age. And that's at a point where they have access to solid food. The next slide, just in a cartoon slide, I had to bring it because this appeared in the Washington Post, illustrated what we mean by blunted thermogenesis. What we mean is that if we were to put these rats in the cold, sort of like what you had in January when I visited, actually it was lower than 5 degrees centigrade, that the lean rat would appropriately increase heat production, maintain body temperature. The obese animal would not, and also would begin to shiver. And at some point in some of these obese rats, body temperature might drop low enough, and they might die, in fact, of hypothermia. The next slide just illustrates this in a more graphic form. And this is a slide taken from data generated by Dr. Barbara Moore, who is now working with Dr. Van Hubbard in the nutrition program at NIH. And what Barbara looked at was in the genetically lean animal, the animal that we didn't know, the heterozygous fatty animal that isn't phenotypically fat, and then the homozygous fatty animal. And what she was able to show that at thermoneutrality, and for a little baby pup at 2 days of age, that would be about 36 degrees, 37 degrees centigrade, that there was a drop in heat production at thermal neutrality. And just sort of remember that these are mils of oxygen consumption expressed in a mass-independent fashion, and what we're seeing here is about 3.5 for this lean animal. Then what Barbara did was she placed them in the cold, 26 degrees centigrade, which, by the way, is quite pleasant for us, for adults. And in fact, heat production or oxygen consumption increased in the lean animal from 3.5 to over 6. And basically, in this fatty animal, while heat production or oxygen consumption increased, the increase was not as great as one saw in the lean animal. And this is really one of the very earliest things that go awry in this genetically obese animal. And this just shows data that Dr. Ruth collected when she was a graduate student, where she did look at hyperinsulinemia, and she did look at 12-day-old Zucker pups. And here, because we were not able to tell who was fat and who wasn't, we basically we compared them to pups that we knew were homozygous lean, because they had a lean mom and a lean dad, and those are the red bars, and that's the lower body fat. The blue bars look at all the offsprings from the mating of fatty males and phenotypically lean but heterozygous females. And what Dr. Ruth did was she declared that all these animals that had a percent body fat greater than this lean, which clearly was an outlier, basically were deemed fatties. And she looked at percent body fat, and in fact, by definition, body fat was higher, because that's how she defined it. But she also measured insulin levels, and I think that this is stunning. In the 12-day-old animal, the plasma insulin levels are elevated. Now, since Dr. Ruth left Davis campus, we now can do these studies in a special animal model, a Zucker-Brown Norway hybrid, where we can identify the animal that's obese by doing an RFLP analysis. And so that we don't, Vanessa would have been happy if this were available when she did her studies. She also went on to look at some aspects of monoamines in the central nervous system. And one of the things she found was an alteration in serotonin metabolism in these pups as early as 12 days of age. Another thing that we've studied in these genetically obese animals is insulin secretion. And in fact, that's a major focus of our laboratory. And here we were perfusing the pancreas in situ. And we even had a preparation where the pancreas was innervated by parasympathetic and sympathetic nervous system. And in the non-innervated pancreas, Amy Kupfert, who was a graduate student a number of years ago, showed that at glucose levels as low as 75 milligrams per deciliter, the pancreas from obese animals really secreted quite a bit more insulin than in lean animals, and in fact, they were hyper-responsive to glucose. Ed Blondes, another former graduate student of mine who is also writing a syndicated column now. I don't know what it is. I drive them out of research and into, that's only 2 of them though. He was perfusing the pancreas at 2 weeks of age, and again, what he found was that there were some animals that hypersecreted insulin, some animals that didn't, and it did relate to their body fat. Again, when Ed did his studies, we could really not determine early on who was obese and who was lean, but it was related to body fat. Julie Lee, another student in our lab, went on to look at some aspects of the central nervous system, of neural input to the pancreas, and in particular, she was interested in muscarinic receptors, and she used the agonist bethanechol to see if in the genetically obese Zucker rat that muscarinic receptors were involved in the production of this hyperinsulinemia. And in fact, she found that they were, and let me walk you through this slide. This is insulin secretion with glucose only with bethanechol. And these are various concentrations of glucose, 75, 125, and 200 milligrams per deciliter. And at minute 21, she added bethanechol into the preparation. And what you can see is at very low level of glucose in the obese animals, that basically there was an enhancement of insulin secretion when she added bethanechol. In fact, it was quite striking. This is the insulin secretion of the animal without bethanechol added to the system. So it was a greater than 3-fold elevation. When she looked at the lean animal, she had to go up, there was no effect at 70 milligrams per deciliter. And basically, in order to achieve the level of insulin secretion that she saw at 75 milligrams per deciliter, she not only had to increase the glucose to 200 milligrams per deciliter, but she also had to use bethanechol. And Julie concluded that, in fact, she felt that muscarinic receptors, that in fact the beta cells of these Zucker obese rats are hypersensitive to muscarinic neuroreceptor stimulation at very low glucose levels. And the hypercholinergic neuroactivity was based on another study. We have now gone on to look at the effect of nutrients on insulin secretion, and that's the studies that I presented this afternoon. And we really feel that the fatty acid arachidonic acid may play a role, or probably plays a role, in hypersecretion of insulin in islets isolated from genetically obese Zucker rats. The question is, what can you take away from this to the clinic? You know, this research hopefully has provided some basic data so that we can find out more about obesity and genetic obesity, but what can you offer your patients? And I still think, based on a study that we published in the American Journal of Clinical Nutrition in 1990, where we looked at women who actually were able to lose 20 pounds and keep it off for at least 2 years, women who never had a weight problem, and women who took 20 pounds off and regained it, this is what emerged from the study. 1, women who kept the weight off, who were successful maintainers, selected a lower fat diet. They also individualized their weight reduction program, their weight loss program, meaning it didn't mean that they didn't go to the Weight Watchers or the Jenny Craigs or whatever, but they took the best from these programs and they adapted it to their needs. They had regular exercise, and I can't tell you what regular exercise meant. We just asked them, do you exercise regularly? And almost 90% of the women who kept the weight off said that they did. Less than 35% of the women who put it back on said that they exercise regularly. They also had better problem-solving skills. And I'll give you an example of problem-solving skills. Women who regain weight tended to practice what we call escape avoidance behavior. And I'll give you an example of escape avoidance behavior versus attack problems directly. as the good maintainers did. That basically both the regainers and the maintainers had similar life crises. But in fact, the maintainers had better problem-solving skills. For example, if something would come up at work and there was a crisis or something at home, the regainers would say, oh, I'll reach for something to eat. Oh, maybe I'll get a little more sleep and when I wake up it'll go away. But the individuals who were successfully able to maintain the weight loss attacked the problems directly. And they also had an excellent social support network where they had 3 or more people that they can turn to for help. Where the regainers didn't, they had 1 or fewer people that could help them in their life events. So I think that based on this study, and other studies as well, they give us some indication as to what we can do to try and optimize individual weight maintenance programs or weight control programs until the time when Jules Hirsch and Rudy Leibel at Rockefeller discovered the gene for obesity in Zucker rats and the genes for obesity. Claude Bouchard in Canada is looking at that as well. Mickey Stunkard at Penn and so on, that are associated with weight gain in individuals. And then it might be easier for us to predict who becomes obese or lean. Now, the reason why I have this up here is because I think it's really important to put everything in perspective. That food is something that should be enjoyed. It's one of life's pleasures. And that there are ways that we can teach obese individuals and individuals who want to maintain a lower weight to try and deal with this. And I actually was really serious when in a Vogue column that I had in 1985, I said, emotionally, I think chocolate should be declared an honorary vitamin, because certainly in my life, chocolate is one of the pleasurable foods. And I just want to thank you for being so patient. But before you ask me questions, Barbara Moore, do you quickly want to tell everybody about this splendid program that you and Van Hubbard are showing to the White House? Or Van, do you want to say something about it that you're showing to the White House tomorrow that we got a chance to see, the CD-ROM program for children 5 to 10? And this is the nutrition education person in me. I don't miss an opportunity to give you a tip that you may really enjoy. Barbara?
Basically, the Dole Food Company and the Society for Nutrition Education have put together a nutrition education program for children between the ages of 5 and 10. And it is a CD-ROM-based program. And it does require equipment, which is rather expensive. I mean, it took us several days of searching at NIH to find a computer that could run it. However, it is available from the Dole Food Company for free to schools that have the equipment that can run this program. They will supply it to those schools for free. Any school in the United States can contact the Dole Food Company and get a copy of this program. At any rate, it's a very interactive program. And we have learned today, we actually played with it today, and we learned that it has elements to it that will teach children geography as well as nutrition and some basics in physiology. And it really is a marvelous program. And I think this is the kind of thing that we need to look very carefully at, is what are children eating and how are they behaving, and is there any way that we can get them to learn how to build a healthier diet more effectively, because we're not doing such a great job at the moment.
And I guess I'd just like to add that I'm very encouraged by this, and I think that hopefully at some point they'll make program for adults too. And I told Barbara and Van that I definitely would not come in singing the song that Broccoli did, because my voice isn't as good as the rap singer on the CD-ROM. But it's really quite wonderful.
At this point, I'd like to open up the time for questions. And for those of you that are asking questions, I would ask that you come down and use the microphone. In the past years, some of the questions have not been heard by the audience, so we have put up microphones this year so that everybody can hear the questions as they are asked.
Thanks, Van. Yes, please.
This is not really a question, it's a comment on one of the things you said at the beginning of your talk. You mentioned the NHANES data that shows, and it's been published pretty widely in the press, that shows that the percent of fat has gone down. I think there's been a misinterpretation of this data.
Good, thanks for the comment.
Fat intake has not gone down. That data shows that fat intake has gone up. I think the data shows that between NHANES 2, it was 36% of calories from fat, but there were 1,969 calories on average, which comes out to 708 fat calories. And it's now 34% of calories, but calories have gone up to 2,200. That makes 748 calories. So between NHANES 2 and NHANES 3, fat intake has gone from 708 to 748 on average. You can't compare percentages of intake when the base that the percent refers to is changing.
Well, we could get possibly into a discussion that I'd be happy for other people to participate. Let's say we actually believed that these data were absolute and there was no wiggle in the collection of the data, which I don't believe. That I think that it's not only the total amount of fat, but it is sort of the distribution of the macronutrients. Because in fact, if you were on a 500 kilocalorie a day diet and you had 80% of your calories from fat, you would lose weight.
I think the data, if you're going to believe if NHANES is going to publish the data and draw conclusions from it, then I think they have to draw the right conclusions. If the data isn't accurate, then let's throw it out and let's not talk about it. But in fact, there is a difference between 700 and 750 calories of fat. It's gone up. I mean, it's like anything else. I mean, if you had several sources of income and one source went down percentage-wise, it could still go up in absolute amounts. What would be really important to you is the number of dollars you got from that source of income, not the percent that it represents. And I think NHANES has to look at this data. They've been misleading the public. And a lot of very smart people have been jumping through hoops trying to explain why people are getting fatter and fat intake is going down when fat intake is going up, and it's consistent with the data. They don't have to jump through any hoops.
Okay. I'd like to just make a quick comment on that. The data that is being reported currently is preliminary data. It has not been presented in full form. To allow for full interpretation. The dietary assessments have been done using different methodologies in previous surveys, so they aren't readily comparable in terms of how the data was collected. And I know that the NHANES people are going back to see how they should best interpret the data, and they have not come out with a final answer there.
Well, if you do talk to them, please tell them that their own data that they're publishing or disseminating shows fat intake going up and not down, period.
Judy,
Gilman, please.
You didn't say anything about people who have a compulsion to eat or overeat way beyond satiety. And I just wonder if you think that the idea of a chocoholic or a foodaholic or a compulsive eater or some kind of addictive behavior can explain any of what you observe or none of it.
Well, again, I think in the Zucker obese rats, it doesn't explain it. But clearly, there is a subset of obese individuals or individuals that have trouble with weight maintenance, that binge eat, that do have classical eating disorders. And again, if we can diagnose this and identify it, we would treat them differently. Or we can treat them differently. Would you like to comment about that? I mean, what do you believe?
Well, speaking personally, I think there is such a thing.
Well, no, we know there's such a thing, personally, right?
No, I mean, people do obviously eat way beyond satiety. The question is why? They know they're full. They're still eating just for the taste at that point, I think.
Well, some of the data that Barbara Rolls has collected, she's now at Penn State, I think are really some compelling data. She basically talks about sensory-induced satiety. I translate that into the Thanksgiving dinner effect. Why, after you have this wonderful Thanksgiving dinner, and your stomach and upper GI and CCK and everything is signaling that you've had too much, and the apple or pumpkin pie comes out, you have pie. And Barbara would say that variety of good-tasting foods leads to increased consumption.
Amen.
Women, too.
You showed a number of results where obese individuals were compared with lean individuals, and say, for example, the obese individuals were exercising less. But with such cross-sectional data, of course, you cannot establish causality. And so I was wondering to what extent there are results from randomized intervention trials where different groups of people are put on different levels of exercise and then followed for weight gain or loss.
Well, there are certainly numerous studies. I would say that the study that I like to quote, I think it was done in published in 1939 by Green. And he was a surgeon, and he looked at change in weight gain or increase in weight gain with forced inactivity. Patients that would come in and they would have broken bones or something, and they would be forced to be inactive. And I hope I'm quoting this right, but about 40% of the individuals that had enforced inactivity really did gain a substantial amount of weight. And some of I thought that if you go back to the classic studies that Ethan Sims did, are you familiar with the prisoners that, in quotes, volunteered to overeat and gain about 20% of their body weight? By the way, we couldn't do these studies nowadays because prisoners are not allowed to give informed consent. But nonetheless, that for some of the prisoners, weight gain was relatively easy. But for others, they not only had to eat a huge amount, but he had to force them to be quite inactive. So that there are individual variabilities, and we've chosen primarily to study this in experimental animals, where we can have an onset or not, and then study it that way. Yes, please?
A question regarding eating. Eating is a reward system.
Yes.
Now, has your lab or any other lab looked at the aspect of increased tone in the dopaminergic system?
Vanessa Ruth, could you please come down and talk about the dopaminergic system in terms of obesity?
I'm across the street at the Uniformed Services University working still in autonomic physiology and serotonin. And consistently, we saw in the ventromedial nucleus and the hypothalamus that either levels of the 5-HIAA, which is the major metabolite of serotonin, or the ratio was reduced in the obese animals. This also occurred in a form of dietary obesity. And we saw it in the genetically obese animals as early as 12 days of age. And adrenalectomy, which tends to normalize to some extent some of the aspects of the obesity, also raised serotonin metabolism.
Vanessa, I thought that you got some changes with the dopaminergic system, and I just can't remember which areas because you looked at so many brain regions.
We only saw it in that first study in males. In the paraventricular nucleus, we saw decreased levels of DOPAC, the major metabolite of dopamine.
Now, I had another sort of follow-up question to that. Now, would there be, since eating in some people is sort of a compulsive behavior, could you treat that type of behavior with pharmacotherapy? There's a product out now. It's been approved by the FDA for compulsive behavior.
Can we answer that question after your comment? Because I'd like to make a comment about pharmacotherapy for obesity in general and more specifically. Yes, please?
I just wanted to address the question about the mesolimbic dopamine system and feeding as a reward system. I've been doing some work in that area, and a man named Bart Hobel at Princeton University also has done a lot of work in that area, as well as other investigators. Basically, the take-home story is there is some increases under some situations in mesolimbic dopamine when feeding occurs. There's also evidence that when animals are exposed to the stimuli associated with feeding, that the dopamine goes up, and we're all still trying to figure out what's related to movement and what's related to the reward systems in feeding, and that's a question that's still under investigation.
Thanks for being a good sport. Just a comment about pharmacotherapy for obesity. the North American Association for the Study of Obesity is trying to address this and come out with a paper that hopefully will be published within the next 4 months to 6 months in obesity research. And what we did was we got together a group of individuals, members of NASO, and we invited people from FDA, from NIH, from 9 or 10 drug companies to join us to first observe us and in our deliberations, and then in our second meeting, which unfortunately occurred that day in Washington in January when the mayor closed down the city. We had a second meeting, and again, everybody participated. And I think that we are at the point of achieving consensus in this area, in that we think that it's appropriate to use drugs to treat obesity, but only as an adjunct of a program that also focuses on improved eating habits, increased physical activity. In other words, it shouldn't be used alone. And we also think it's probably appropriate for a number of people that respond positively by lowering their body weight for them to be on it chronically. And I must say, I've never understood this paradox. If you had a patient with hypertension and you decided to put him or her on a blood pressure lowering drug, and let's say blood pressure did respond positively, meaning it lowered, you wouldn't just say, well, now we can take the drug off because we've corrected your blood pressure. Because when you'd remove the drug, what would happen? Blood pressure would go back up. I've always found it curious in the obesity area that we put obese patients on drugs, their body weight goes down, we take them off drugs, the body weight goes back up, and we say the drug has failed. It's a bit curious, don't you think? So we're hoping that the climate, the regulatory climate, hopefully will change so that, one, FDA can begin approving drugs to treat obesity. There hasn't been a new one in this country approved in the last, I think it's 19 years. Also, there are regulations in certain states that if physicians use drugs to treat obesity for longer than 3 months, and California is one of those states, they can lose their license. So you're not allowed to treat patients long-term with drugs. They can be on a research protocol, but right now it isn't appropriate. So hopefully we'll be able to contribute to changing this climate because we're not giving the obese individual access to the full battery of things that we think that can help in weight management.
I just wondered if maybe limiting access to certain foods encourage this binge eating syndrome by creating forbidden food lists in our clinical patients. I found in rodent studies that if you limit access to preferred foods, the rats eat tremendous amounts of this food in a very short amount of time. It almost mimics a binge like you might see in the clinic. And when I was working clinically, in the patients that had forbidden food lists and they self-restricted access to these kinds of food through self-imposed limitations, or in environmental situations where your favorite kind of ethnic food is not available and you have to drive long distances, you eat a lot of it when you finally get there. But maybe clinically, one of the things that might help control these kind of compulsive large amounts of intake that we see might be to get away from these forbidden food lists and encourage patients to build into their diets the foods that they fear the most.
Well, certainly that's been one of the approaches in behavioral therapy, where you encourage the person to plan to eat some favored foods, to plan to eat them in limited quantities at a time when they're not very hungry. Comment?
I wonder if you'd talk a minute about, you mentioned exercise, but about what type, or in terms of what percent of VO2 max. The implication of some of what you said is maybe daily is better. What about weight training so you can increase lean body mass?
Sure. There's been certainly studies that have been published to show that weight training can help if it's associated with an increase in lean body mass. Typically, swimming isn't an exercise that's associated with improvement, with decrease in body fat or dramatic decreases in body fat, although cardiovascular fitness is one of the very positive benefits of swimming. In terms of the studies that we've done in terms of metabolic rate are talking about 60% or 65% of VO2 max. But the study that I like to quote was a study by Dr. Gwinnett. He did it in Southern California, and all he did over the course of a year was encourage his patients to walk. And these were overweight patients, and those who walked an average of 30 minutes or more a day lost a significant amount of pounds. I can't remember if it was 8 or 10 pounds in a given year. Those that didn't lose weight. So I think that what I would say if I were in the clinic, I would try and assess physical activity. If your patient is active, that isn't an area in which you want to encourage further activity, perhaps. But if they're willing to make some changes, maybe just using that pedometer would help. I know that if there are studies that come out of the University of Wisconsin that if they have to rely on special places to go, like health clubs, if they're a distance away from where they work or live, they tend not to do it. There was an interesting study done at the University of Wisconsin where they studied professors. And they were enrolled in this physical activity, and what came out of this study was professors whose offices were closer to the gym stuck with the program longer. Now, I probably could have told them that, but I guess it's important to find that out. So again, it's important to individualize the programs and not to even maybe just focus on one activity. And Dr. Rod Dishman out of University of Georgia has published some excellent things in this area.
I just comment, I think since we have literally tens of millions of Americans trying this intervention of exercise, that we should have some modest clinical trial type things about various variations, does 15 minutes help? I compare that to 30, and so on, different types of updating the clinical stuff, and so on, because we really have an enormous amount of people trying very hard, spending a lot of money on this, and not waiting for a drug or a genetic.
Well, there are studies in the literature in terms of the amount and type and frequency in terms of physical activity. Gil?
Well, we haven't thought of obesity as being a disease, and that's why we don't want to treat it with medicine. You think of hypertension as being a disorder or a disease, and we're in allopathic medicine, so we think, well, they've got a disease, treat it with medicine. But obese people tell us, and we tell them, they're normal, they're healthy, they don't have a disease. Why should we treat them with medicine? That's where that reluctance comes from.
Well, I think it's just sort of, I have a different approach to that. I think that I know we discriminate against obese people. We call it a willful disease, that if they only watched what they ate and they were physically active, there wouldn't be any obesity. And in fact, I like the best solution to obesity. Vogue, which I call vague, when I wrote for it, certainly wasn't in touch with the real world, although my columns were. But Grace Mirabella, the editor of Vogue then, said she had the cure for obesity. You know what it was? Don't make any women's clothes greater than size 8. Now, that to me symbolizes what we think about obesity. Physicians feel the same way. And our genetically obese rats are obese. They have an underlying disease, and they die sooner than genetically lean rats. We're doing some longevity studies, Ruben. You'll be interested to know. So, and I thought that NIH did declare obesity a disease, but yet physicians under a lot of health plans cannot treat obesity.
Obese people don't want to say it's a disease. You got to realize that, and it's important. The whole groups of women that get together that say we're healthy, we love our fat, they get big Berthas, and there's a new book coming out from California showing beautiful nude women that are 400 pounds. They think they're healthy.
And Gil, I guess what I would say in answer to that is, if we talk about weight management, let's say they don't want to lose weight, but maybe they can improve their metabolic fitness. They can be more active. They can cut back on fat in their diet. They can do other things other than losing weight to improve their metabolic profile. And what I would say is, if their parents died of diseases, premature heart disease, had type 2 diabetes, then and if they had an increased waist-hip ratio, I'd say, boy, you may be healthy now, but this may foretell your future, and when you want to do something about it, we will offer you something. Until then, please feel good about yourself.
More
noticed,
comments on the right, and then I think we'll call it.
I noticed you talked quite a bit about the compulsion and not a lot about the obsession with people who consider themselves to be compulsive overeaters. And I am in that group. And I had this question to ask. Does the amount of time a formerly obese person maintains normal weight have an impact on the decrease of fat cells and metabolic levels?
Well, that's an excellent question. The problem is you never lose a fat cell. When you lose weight, your fat cells get smaller. And then when you regain it, they just refill. And you can actually get more fat cells, but it's hard, you don't get less. And so one of the reasons why it was thought that obese individuals regain weight was that for individuals that have many more fat cells, when they lose weight and maybe their body weight is normal, their fat cells are very small. And they may be more responsive or to refilling with fat, so that you never really lose the fat cells. And surgical procedures simply can't remove enough. And we even have some evidence in rats that even if you remove fat cells, they regrow. We did liposuction on half of a side of a Zucker rat.
Thanks, but no thanks.
Right. Guess what? I'm with you.
Thank you, Judy. And I did note that you didn't say anything about your favorite exercise or favorite sport, baseball. Okay. Again, I'd like to remind you that if you'd like to be placed on a mailing list for future lectures or other activities relating to the nutrition programs here, please put your name on the pad. It's a Healthy Kids pad that I had in my briefcase, so you can identify it in the back table. I'm a pediatrician. And then the next lecture will be April 13th, again at 7 p.m., again on a Wednesday evening. I hope to see you all there. Thank you.